Page 3 starts out with regression given a set of data. Now, unless I ask you to determine the degree beforehand, then we're not doing the set of differences because this data is not perfect. This is somewhat more random, and you have to find the function that best fits it. So what I want to do first is make sure that when we do our regression, we're going to find our correlation coefficients or coefficient of determination. So in linear, I should have changed that back to an R. So for linear, we do R. Alright, so we're going to go to Stat Edit and clear out what's in there. Clear Enter. If you delete your list, that's fine. Just actually delete them all. You just go up there and you press Delete on all of them. And then you just go back to the first one and you go second. You press Enter and you go second. And above 1, it has List 1. And you just rename them all. Okay? My x's are 0 through 5, so 0, 1, 2, 3, 4, 5, and my y's are 10. Just kidding. I have to go to the next column. 10, 12, 48, 145, 340, and 600. It's just asking me to do linear, quadratic, cubic, and quartic regression, so second quit. I want to make sure I can see those. So everyone go to mode. You need to go to mode if you haven't already, and you go up to stat diagnostics and make sure that is switched to on. Mine is, so second quit, and I'm going to go back to stat, and I want to perform a linear regression. So I go to calculate, and then I do linreg number 4. If you want to store in your y equals, all it's asking me to do is find them, so I don't need to store in y equals, but I would press alpha and then trace, and then press enter. But I don't need to, so I just press enter, and there we go. I get y equals 115.171x, because that's A, and then B is minus 95.429. I'm always going to round. You don't have to, though, so if you put 0.428, that would be fine. And then my R is 0.916, or 0.915. Right now I'm going to do a quadratic, so calculate, stat calculate, go down to quadreg. I don't want to store it, so I press enter. And I get y equals 34.393x squared minus 56.793x plus 19.214. And my fit is a 0.998. Which is pretty good. Cubic, so stat calculate cubic regression, which is number 6. Press enter, and I get y equals, and I realize that you're going to run out of space. We'll just double over. 2.463x cubed plus 15.921x squared minus 23.050x plus 11.825. And my fit is a 0.999. And then quartic stat, calculate, let's do a quartic regression. And I get this. Y equals negative 1.25x to the 4th plus 14.963x cubed minus 22.472x squared plus 12.664x plus 9.683. And then my fit is a 0.999. It has one more 9 after that, which makes it a slightly better fit than the cubic. But I'm not asking about any of that, so just there you go. Number 15 is similar, but I'm only asking you to find 2 regressions, and then I'm asking you to do to find some things. So, give me a second to highlight, and then I'll enter the data. Okay, 15. Stat, edit. My x's are not the same, so I'm just going to go ahead and delete that too. 1, 2, 5, 6, 8, 9, and 10. Now, it would be very much in your interest to make sure that you have the data entered correctly. I didn't check on the last one, but I was pretty careful entering it in. But it would definitely be worth your time to make sure, like after you've entered the data, that what you've entered is correct. So I'm going to do that now. 38, 37, 35, 32, 31, 28, and 27. Okay. 1, 2, 5, 6, 8, 9, 10. All right. I need to do a linear regression, so I go stat, calculate. I want to do linreg, number 4. This part right here says use the quadratic model, so I don't need to store the linear, so I'm just going to go ahead and go to calculate. And I get y equals 1.236x plus 25.333, and we use r, so 0.993 on linear. And then for the quadratic, I'm going to go stat, calculate, quadreg. Now, right here, because I'm going to use the model to do things, I'm going to store it. So I'm going to go alpha trace and enter in y1. Press enter. And I've got y equals 0.053x squared plus 0.661x plus 26.347 with a fit of 0.997, so slightly better. Now, if you want to actually see the data, just go to Window. Make sure you can see the x's, so let's go 0 to 11. And the y's range from 27 to 35, so I'm going to go 0 to 50. And I'm going to go to second stat plot, because our plot you might have changed to the bar graph. So you switch that to on, and then you make sure you're on the dotted. Okay. Another way to do it is just to go to y equals and go up and press enter to make sure plot 1 is on. But if I press graph, I'm going to see the data, and I'm going to see the beginnings of my, this is a very wide quadratic, but it fits it slightly better than the linear. Okay. So it says use the quadratic model to answer the following. Predict the y value when x equals 24. So when x equals 24, well, I can just go to my table because I've stored this in y equals and just look at 24. If you don't want to scroll, you can always go to second table set and either have it start at 24 or, sorry, you can't see that. Either have it start at 24 or go to ask instead of auto on independent and then just type it in. So if I just said start at 24 and then I went to the table, then it would tell me right there. And so the y value when x equals 24 is 72.695. Now this says predict the x value when y equals 46. So I'm going to go to y equals. Because what I can't do is I can't just be like, well, it doesn't let you scroll on the, well, it does let you scroll down, but it won't let you scroll up. So what I want to do is I want to go back to the graph, or I'm going to go to y equals. I want to know when this function equals 46, yeah? So I want to know when y equals 46. So I'm going to graph 46, and I can see 46 on my window. But my x is not so much, so I'm going to go negative 25 to 25 and just see what happens. And I've got the parabola, and I've got 46. Now I can see this one, but I can't see that one, and I want to go ahead and find both in case I were to need the other one. So I'm going to go window, I'm going to go further to the left, so negative 40, and I think 25 is fine. Alright, so I see I have two intersections. Predict the x value and y equals 46. So now, if this were modeling like an actual situation, the negative probably wouldn't be a thing. I probably wouldn't make that part of my answer, but because I didn't make it part of a situation, I can't really say whether or not that's true. So I'm going to go second calculate and just do the intersection. Now, whatever this blinky dude is, I've got two intersections. If I just press enter, 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 it's going to find whichever one it's closest to, so it finds that one. Negative 26.511. And the other one, if I go second calculate and I want to find the intersection number 5, I just need to make sure that I'm closer to that intersection. So I just scroll closer to it, and once I'm closer to it, I can just press enter, 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 and there we go. And there are my two intersections. The next function, the next problem, I'll talk about highlight, is about exponential functions, those exponential growth and decays, and what they look like. So the first thing I'm going to do is type in my y equals. Now it's 0.32 to the x. Now 0.32, I don't know if you remember growth and decay, but it's the initial amount times 1 plus or minus the rate to the t, or to the x, whatever you wanted to say. And then this actually has a vertical shift. But the rate is whatever you're adding or subtracting from 1. Okay? So since 0.32, which is the thing being raised to the power, is 1 minus something, I know right off the bat that this is decay. Alright? But I'm going to go ahead and type it in. My plot 1 is on. That could create issues, so I'm going to go up to it and press enter, and now it's no longer highlighted. Clear and clear, and we type in 0.3, I don't know why I said negative, 0.32 to the x, and then minus 3. And I'm going to go zoom, well, I'm going to go to this window. Negative 6 to 6, and negative 4 to 30. Press graph, and here's what I've got. Okay, so I can definitely tell that it's decaying. It's going from above to below, or to negative infinity. Well, it's not going to negative infinity, but it's going down. Okay, so as far as what the rate is, I have to think, okay, 0.32 is 1 minus what? Okay, so the easiest way to do that is just to go 1 minus 0.32, and it is 1 minus 0.68. So it is a 68% rate of decay, or 0.68. So you can either say 0.68 or 68%. Okay? I actually do need to plot these points, so this graph, I'm going to go ahead and go to my table and do that real quick so I can have it. So second table, and I'm going to go table start and have it start at negative 4. Let's see what happens. Second table. At negative 4, I'm at 92, and I cannot see that. At negative 3, I'm at 27.5. So at negative 3, I'm at 27.5. So there's 27, so 27.5 is somewhere in there. At negative 2, I'm at 6.7, 6.8. So at negative 2, I'm at almost 7, so somewhere in there. At negative 1, I'm at 0.125. So at negative 1, so there's 1, 0.125, which is right there. At 0, I'm at negative 2. At 1, I'm at negative 2.68. So there's negative 3. So somewhere in there. Negative 2.8, so almost negative 3, getting closer to negative 3, but not actually reaching it. It says negative 3, but if you look down here, it actually says a decimal close to it, but not actually that number. Which makes sense because I don't know if you remember, but exponential functions have a horizontal asymptote that models the behavior. So I connect these points. And it does say in the directions to draw and label the asymptotes, so that's fine. We just got a Robert yelling. Okay. You should have, never mind. Okay, so I've got my horizontal asymptote, and that is at y equals negative 3, and that is just the vertical shift right there. Whatever you're approaching, that's the asymptote. So I'll go ahead and put that right there. Y equals a negative 3. As far as domain and range goes, domain is how far left and right it goes. This goes all the way left and all the way to the right, so my domain is all real numbers. But my range is low to high. The lowest you actually go is negative 3, but you do not actually reach it because of the horizontal asymptote, so I'm going to press. I'm going to put in parentheses, and then we go up to infinity. The end behavior is a little bit more interesting. As you go left, when you go left, the function is going up to positive infinity. But when you go right, you're actually just leveling off to negative 3. And so there's my end behavior. My x-intercept is where I cross the x-axis, and I don't actually have that point. So I'm going to go second calculate the 0 to find the x-intercept. And we're going left and right of the 0, and I press enter. And I get that the x-intercept, thank you, Natalie, is negative 0.964 comma 0. So there's my x-intercept. And then my y-intercept was actually negative 2. I remember that from plotting it. So that is the point 0, negative 2. And then the last thing is the average rate of change, and a lot of people struggle on that. Average rate of change is on this x interval. This is an x1 and this is an x2. I want the slope, basically, between this point and this point. So we're finding this slope right here for average rate of change. So I need the y values at x equals negative 2 and positive 2, so I can say down, rise over run, or how much we go down, how much we go right. So I'm going to go back to my table. Okay, so if you make a little chart, it might help you. Your x values are negative 2 and positive 2. Your y values are 6.7656 and negative 2.8976. So we'll do slope formula, which is y2 minus y1 over x2 minus x1. So that is negative 2.8976 minus 6.7656 over 2 minus a negative 2. Oof, almost forgot. So negative 2.8976 minus 6.7656, and then divided by 4. And that is negative 2.4158, or negative 2.416. And that is the average rate of change. And that is page 3.